The open source community is leaving no stone unturned. They are fighting tooth and nail to catch up with whatever innovations that is happening in the corporate world, whatever new things that is coming up by the closed source private organizations like OpenAI or Google or Microsoft or any other big organizations. For example, a few days back on February 2nd, OpenAI have launched their deep research agent, which have actually taken storm in the internet. You may have seen a lot of videos. Now, within 24 hours, the open source community have created its own project to replicate or to catch up particular deep research agent, and they named it Open Research Agent, which is what we are going to explore in this video in as much as detail possible. And while I'll show you the paper, I'll show you the code, and I'll also show you how to run this agent. Now, this is all started a few weeks back with the DeepSeek R1 release, and I feel like this is going to continue in the days to come. So without wasting any more time, let's get to the screen and let's see what this is all about, because there's a lot of things to cover in this particular tutorial. So see you onto the tutorial. So as you can see, there have been a lot of tabs that are open and there are a lot of code that I have to go through. So let's start one by one. I'm just going to quickly show you this link to start with. If you are new to this news, I'm sure you may have heard it by this time because this has taken storm, as I've said. So OpenAI have launched their deep research on February 2nd, 2025. And this is more sort of a multi-step research task or agent where you can give a task and it will search internet, look for different type of files, websites, links, images, videos, or anything and everything that is available there in the internet. It will do its own analysis. It will do deep thinking. For example, whether the fact that it is checking or reading is actually fact-checked data or not. And based on that, it will do the research. For each and every research, it might take 5 to 30 minutes. And this is only available as of now to pro users, which is like the $200 per month user, which is not, of course, you and me, unfortunately, but because, of course, we are not that rich. Jokes apart, what has happened was as soon as this deep research agent have been launched, there is a team in Huggingface who have started working on this, and they have set a 24-hour time-boxed research, and they came up with a very similar deep research agent, which is they are calling as Open Deep Search. Now, what this is about, I'm just going to quickly go through this particular link, and then what I'll do, I will take you through the code, and I'll explain you what is happening in the code step by step so that you understand it, how it is all working. Now, let's read it through very quickly. So basically, they said that OpenAI released the deep research, a system that browses web to summarize content, answer questions based on summary. This system is impressive and blew our minds when we tried the first time. And I think it's blew a lot of people's mind, really. And there has been a speculation that it is going to replace around 3% of the worker across the world, which is also something which is scary. However, the way OpenAI has came up with their benchmark is based on something called Humanity's Last Exam. So what is Humanity's Last Exam? This is again an open source dataset that contains around approximately 3,000 questions. And these are the really difficult questions. And I'll actually show you an example of those questions, how those looks like. And these are basically across different domains. As you can see, there are math question around 42%, physics question, biology, humanities, engineering, and everything else. And so far, the models have been really, really struggling. I think the best model so far was DeepSeek R1 that has got 9% accuracy. However, I think OpenAI have claimed somewhere when I was reading that they have claimed that you're able to get around 26% in search with that. So they have got 26.6% accuracy over these question datasets, which is the highest so far. And that is really, really impressive. But how did this particular agent was benchmarked? So basically, very similar to HLE dataset, Huggingface have also came up with their own dataset a few months back that they called as GAIA, or General AI Assistant Benchmark. And how this GAIA benchmark works, I'll show you in more details while I'll explain you the code. But basically, this dataset contains, again, similarly, over, I don't know, 700 or 800 questions from different domains. And these are all questions that are agentic based, not like normal question answer based. So this is to basically test an agent's performance. And so far, what they said that with the OpenAI's deep search, they are able to successfully reach nearly 67% correct answer on one shot on average, and only 47.6% on level 3 questions. So there are different level of questions in this particular data set. And with one shot average, overall, it has got 67%. However, for the challenging question, it has only got 47.6%. This is the OpenAI's deep search. However, what Huggingface is claiming is that we now have more strong open source model like DeepSeek R1. And because OpenAI didn't disclose much about the agentic framework underlying the deep research project, they have actually used their existing agentic framework, which is SMOLAgents, and then they created a deep research open source project. Now, if you don't know how SMOLAgent works, it's a small agentic framework. It's a really effective framework because it has a coding agent, and I have actually covered about this in my channel in much details. So there is actually a mini course in my channel. So if you go to the channel, you will see this video, which is about a month back. I have created this crash course where I have explained everything that you need to know about SMOLAgent. So please go through this course if you're not sure what SMOLAgent is. Now, what they have done basically is they have used the code agent within the SMOLAgent library, which is really, really powerful agent to power up this particular open research project. So code agent is basically here is deciding the orchestration of the agentic flow. So they have created a bunch of tools. They have given this GAIA dataset to this particular deep research agent, and they are basically running this deep research agent, which will use the code agent to do different analysis. And you can definitely use strong models like DeepSeek or GPT-4o or GPT-4 O3 model or any other open source model. Now, one of the question, as you can see here, they have explained here, is showing the complexity of the questions that is tested under this GAIA dataset. Like, one of the question is, which of the fruit shown in the 2008 painting embroidery from Uzbekistan were served as part of October 1949 breakfast menu for ocean liner that was later used as a floating prop for the film The Last Voyage? Give the item as a comma-separated list, ordering them in a clockwise based on the arrangement in the painting started from the 12 o'clock positions. Use the plural from each unit. So this question is really, really complicated question, even for a human to answer, right? Because it has got several challenges, as they have mentioned here. It needs to know the knowledge. It needs to answer in a constraint format. It needs to also have multimodal capabilities because it needs to see the painting. First it needs to find the painting, then it needs to see the painting, then it needs to identify the objects. So the model also needs to have the ability to distinguish objects from an image, and then it needs to find which ocean liner was used as a floating prop as last voyage, and then the model or the agent needs to chain together a problem solving thinking process or trajectory to give the answer in the correct order, right? So this needs really, really high level planning and detailed executions to be able to answer this. And that is why they have used the code agent, as I was telling you. The reason why the code actions are much concise than JSON is because it can actually self-correct, and it can just write few lines of code rather than continuously doing the research, returning JSON, and then finding if the JSON is not correct, and then again do the research, get the JSON. So instead of that, it can just write some code, and it can fetch data from a file or from a link or from an image as it requires. So it needs fewer token than if you are only dependent on JSON structure-based tool calling, right? So that's how they are getting a better benchmark. And I think somewhere they said that with this data set, they are able to get almost 54%, which is commendable, because the OpenAI's deep research was getting around 67%, whereas they are getting 54% on the validation set, and then on the Magentic one, they are getting 46%. Now, so what they are getting is, with this framework, 54% on the validation set, whereas previously they have only got with 46%. Now, this is really, really interesting, and they have created a live demo page, which is this Gradio app. And you can, if you go to this link and click here, you will be able to go to this particular Gradio link, and you can give a request here, and that it will process. For example, let me actually initiate that because it will take some time. So let me go to the code base and let me copy this question. Now, this question is the same question that OpenAI has been asking here in this video. So that is why we wanted to test it, right? The same level of thinking. That's what we want to test. So it is queued around, currently at 74. I don't think I'll ever get answer with this space, because this space is being used hugely, and you can imagine, because this is again open source power. So this was one of the reason why I thought I would actually clone the code and try to run it, and that's what I have done. So if you go to their repository, they have shared this. This is open source again, so you can actually go there, and here in the repository, you will go to the examples. So this is the SMOLAgent repository. In the example, you will see this Open Deep Research folder. And in this Open Deep Research folder, you have this particular few files. You just have to clone this particular repository and you need to run it. But unfortunately, it doesn't just run straight away. There are a lot of issues that I have at least faced when I was trying to run this. However, it took almost 2 to 3 hours for me to fix all those issues to be able to run this particular agent. Now, what I'll do, I'll go to the code base and I'll exactly show you how to run the code, what all things that you need beforehand, and what all improvement that I had to do in order to run this project. Before going there, one last thing that I should be mentioning it here is this particular agent that they have created. This was created only within 24 hours, so they haven't used a proper web browser environment that might be the operator agent is using in case of OpenAI. So they have created a simple text inspector agent, which is just fetching the text file from the web when it is doing scraping. If you use beta scraper, beta web search tool, I think the result will eventually become even improved version. So with that said, let's go to the code base and let's explore the code base. What we have to do is, in the code base, after I have cloned this repository, I had to update the requirement.txt. Here I have added a bunch of extra modules that I needed to run this. I have also added a guide.md file, which was not available, and it was really painful to understand how to run this. So you can now follow this guide and you can run this. You can run this code like their existing code, and also I have created one code myself based on their run.py to test specific questions. So basically their run.py, what it downloads the GAIA dataset and it runs over it. So that's how it does it. However, I wanted to also test a single question, not specifically test the benchmark. I wanted to see whether it is able to do the research for me. And that's why I created a test question py file, and this py file will actually take question from you exactly similar how OpenAI is putting questions here. So it will accept questions and it will do the research for you using the open source model. Now, there are a bunch of folders, as you can see, it's created. Now, this is one of the problem with this particular script, that it was not pre-downloading the dataset. It was only downloading the question, but the questions, if I show you, it is referring the dataset. For example, let's go to the dataset very quickly. And let's go to the GAIA release here. Now let's say this question. It says that the ATAS spreadsheet shows the inventory for a movie and a video game rental store in Seattle, Washington. What is the title of the oldest Blu-ray recorded in this spreadsheet? Return it as appear in the spreadsheet. That means this question need a spreadsheet to be attached, right, for the research. Where do you find the spreadsheet? So there is this task ID and then there is a file name. So this file you have to download from this files and version, go to 2023 and then go to validation, and here you will actually search this data and you will see the dataset. So you have to download this dataset and you will see there are a bunch of different type of dataset. There is a Python script, there is style sheet, there could be doc, there could be zip file, JSON file, MP3 file, PPTX. So your dataset could have different forms, and using this particular data, there are questions. Now, not all questions have data associated with it, of course, because there are more than 300 and 400 questions, and there are only few data, as you can see. So not all data actually have a particular file associated with it. So there could be questions which needs web search and different other mechanism as well. Maybe go to YouTube and see a video or something like that. So that is the reason why they have defined this many tools. So when you go to the script folder, you will see bunch of Python file here, and these files are basically helping creating the tools like conversion tools. If you want to convert something to Markdown, if you want to do some text inspection, you have text inspector tools. So they have defined bunch of tools here, and they're using simple text browser. As I have said, they're not using a full-fledged browser. That's something we can improve, or you can improve in this project because it's open source. And what they are doing is they are using the light LLM model class. So using the light LLM model, you can access 100 plus models that is out there. So you can use any model to basically run this project. This is open source, as I said, so you can use that. However, there are some key differences that I faced when I tried to run it. First thing first was the script that is available here in this repository doesn't download the dataset. The dataset means the file reference and everything. So this file reference, you have to download it manually to be able to run this. That's not mentioned anywhere in the documentation. So that is why I have created the guide.md for you. The second thing that I have done is I have added this section. And this section is checking if you have a Huggingface token. And if you have a Huggingface token attached, then it will actually download the dataset for you. So if you use this script instead, I will again upload this entire script, whatever I have made changes in the repository. You will get the link from down the description, absolutely free, no charge. So if you use this script, will actually download the dataset. But this dataset is not available if you just run the script. I think you just have to create an account in Huggingface and accept the terms and conditions. However, it doesn't cost you anything. So you just need to go to the account, verify your account and click accept, and then you will have access to the dataset. And then if you run the script, you don't have to worry about it because this will actually download all the dataset, all the files automatically, and it will keep all those files inside the data folder, as you can see here. So it will keep it here. That is one thing that I have added. The second thing was whenever I was trying to run the agent, it was failing badly. The reason is because if you see their code, I'll just go through the code here. Here, as I was saying, they are using a bunch of tools, and then they are creating two agents. One is their manager agent, which is a code agent that can actually write code. And then they have tool agent or tool calling agent. And this tool calling agent will use these tools. Now, the way Smolagent works is because you're running the code agent in your local system, you should be really, really careful because it will write code and run it in your local system. So that is the reason why you can fully authorize the module that the code agent can use. So anything else, if the code agent need outside of this import, it won't be able to import and execute or run. So that is the way you can safeguard yourself if you're running small tool code agents. I have again covered all of this in much detail in the Smolagent tutorial, so you should go ahead and check that. So this tool calling agent have few of the parameter mentioned here, which is like name, description, provide run summary, manage agent prompt. These particular arguments are not available in the out-of-the-box tool calling agent. So if you go to the Smolagent package and inside tool calling agent, Actually, I can show you that. You can go here. So if you go to the tool calling agent init method, you see these particular parameters are different. This is different than what they are sending here. So what we have to do is we have to create a wrapper of a managed agent, because if you search for managed agent in this particular code, so managed agent actually have got all of this name, description, managed agent prompt. So that means if you download the or clone the run.py as it is available here, you will not be able to run, possibly. At least I was not able to run it. So I had to make a lot of changes to this code. I have to create a custom ToolAgent. So I'll just show you quickly. So here, if you see, we had to wrap the ToolAgents of the text web browser agent as a managed agent, and then only we were able to use it. Otherwise, we are not able to use that. Again, these are the two things that I have added, which is marked as yellow, like pre-process file, but then download GAIA file. These functions are used to download all those files. And the third thing that we have to again update, which was not working, was to do with LiteLLM. Here, this bit. Now, again, go back here just to show. If you see the original code that is available in the SMOLAgent repository, have all of these extra parameters mentioned here, which is what not supported by the LiteLLM model class that is available. So I had to actually literally go to the library code of LiteLLM model to find out that it is not there. Also, the default model, if you do not specify this argument when you run the script, it uses the default model as O1. There is no model ID in LiteLLM class that accept O1 as a model ID. It accepts GPT-4o, it accepts O1 mini and O1-preview. It doesn't accept just O1. So I am not really sure if anyone have actually yet tried it, and if someone from Huggingface team is seeing this video, probably can help me understand this, maybe in the comments, or if you have run this, as it is exact from how you're able to run this, but I was not able to run it, and probably I've been missing something. Now, that is why what I had to do, I had to remove all those extra parameters from this particular code, just use model ID to be able to run it, and then only I was able to run it, frankly. Now, how would you run it? Very interesting. How you can run it is very simple. I'll just show you. And I'm not going to rerun you because I've already spent more than $5 when I was testing this. So I'm just going to show you how you can run it. You just need to first create a Python environment. Then you install the requirement file as you will get as part of this code base. If you want to use my code base, the modified one, feel free to do that. And again, use the link and download it. And then once you install all the requirements, then use Python run.py, then give the model ID as GPT-4o or anything else which LiteLLM accepts. So if you're using OpenAI, you need to also add the OpenAI API key here and SERP API key here if you want to do Google search. If you want to do some research using this particular code and that needs any kind of search to be made into the web, you need a SERP API. So add the SERP API, add your Huggingface token because it needs to download the model. And of course, I am using the OpenAI API key because I had to use the GPT-4o model to test it. But if you can use DeepSeek R1 or something else, or if you want me to test it using DeepSeek R1 or any other model of local Olama, I'm happy to do that. It's not a big deal. But I have skipped that part because otherwise this video will become, 2 hours long. You can set concurrency. So I have just set 1 so that it doesn't create a lot of thread and cost me a lot of money. If you want, you can set multiple concurrency and run this particular agent, and it will download the question set for the GAIA dataset, and then it will run all of these questions one by one. For example, if you take this example, just to show you, I think the initial bit was gone, but what it is doing. So the task is find the physics and society articles submitted on August 11, 2026. And this is the task. Your final answer should have task outcome, which is the short version, extremely detailed version, and additional context. So this was the task it was working on. And then it has did the web search. It has got different paper. It started visiting all those page one by one. After the web search, it got all those details one by one, and then it called the tool to create a final answer. So this is just the final answer. It was created. So as you can see in the task, there were 3 tasks, right? One was to do the short version, and then extremely detailed, and then additional context. So that is why here it found that it needs to do some more research. So then it started doing more research, and then it created a new plan how it will do that. There are 4-step plan, and then it started doing all the 4 steps one by one, as you can see here. It then created Python code. As I was saying, it's a code agent, so it can write code. So when it found out that there is a PDF file which it was not able to read using the text tool that it had, so it had to create a Python file. So it created a Python file. It parsed all the detail within the PDF like this one, and then it started doing further analysis. Again, it written another Python code to search for this particular keywords within that PDF to get some answers. So as you can see, it was doing a lot of research, and by this time, I think it has already had 130,000 input token and 2,300 output token using GPT-4o model. I was running it, and it was almost costed me around $2 by this time, and I stopped it. But as I said, if you want, you can run it and you can test benchmark basically. And then if you are done with this one, if you want to run the test question.python file, which is where you can actually do your own research question like the OpenAI model, what you will do is in this bash terminal, you see I have run this particular file. And again, the same question, I have defined the question that create a research report for past 3 years, use bullet and tables for necessary for clarity. And then I have used GPT-4o model. Of course, I could have used GPT-1 or something else for better answer, but I just wanted to test this and show you how to use it. I would probably use this DeepSeek model later on for my own use cases, but this is how it did it. As you can see, it did a lot of research. It took almost 3 minutes to complete the research. It says that it had started from 25:55 and it was completed at 12 a.m. 28:55, which is like 3 minutes exactly. And then it has created the final report, the key points, the changes in the consumer behavior, the economic impact, adaptations, and then it has given the detailed insight as well. And then it has created table as well, because we have asked to give it in a table format. Now, this really looks promising, I would say. If I would have used a model, I think it would have even created some better result, not like this minimal result, but it clearly did a lot of research because that's what I have seen. It has literally went through a lot of paper. It did a lot of web search. It created some code as and when it needed. So it did a lot of thinking. And although we use GPT-4o model, which really don't have a lot of thinking capability, it was still able to do nice research. I will update what I will do next. Maybe I will use DeepSeek model and see how the performance comes up. I'll probably create a post later on. If you are interested, let me know in the comments. But yeah, I will leave you with this particular code. So again, just to repeat the same thing again, download this particular code from the link. So what I'll do, I'll create a separate project for this one in my own GitHub repository, and I'll share this and you will find the link there in the video description. So download this one. You would be able to run it smoothly. You don't have to face a lot of issues because I have already spent a couple of hours to fix the code so that you are able to use it. With that said, I'm going to end the video. If you have really learned something new, or if this kind of video is really helpful to you, please make sure give it a share and subscribe to the channel, which is a must, because you can see there is a lot of interesting stuff that I try to cover in this channel. And with that said, I'm going to end the video. Please take care, and I'll see you on to the next one.